Welcome to qnawire.
Let's first find the distance that just the first stage travels. So the distance that the first stage travels, let's call that y1, is going to just be equal to 1/2 times the acceleration times t squared, since its initial velocity and position are both 0. So plugging in numbers, that's 1/2 times 3.50 times 25 squared, which gives us distance of 1,093.75 meters. Now let's find final velocity just during this first stage. So again, we know that final velocity, which is the initial velocity plus acceleration times time. In our case, the initial velocity was 0. So let's call this, to be consistent, let's call this v1. So this is the velocity after just the first stage. It's just going to be equal to 3.50 times 25.0, that 0.0 as well. That's going to give us final velocity after the first stage of 87.5 meters per second. Okay. So now let's find the acceleration during the second stage. So in this case, we're actually given the final velocity after the second stage, acceleration. And we know that that final velocity is 132.5 meters per second. Setting that equal to the final velocity after the first stage plus this new acceleration, and I should denote that this is acceleration 1, 2 accelerations here, acceleration 2, times t, and t was 10 seconds. Gives us second stage acceleration of 4.50 meters per second squared. Okay, so now if we want to find the height after both the first and second stages, we put all this together. So that y2 equal to the position after y1, or the position after the first stage, which is the answer we got over here, plus the velocity after the first stage times the duration of firing during the second stage, which is 10 seconds, plus 1/2 times this new acceleration a2, over a bit, times 10 squared. Which gives us a y2, which is equal to the maximum height that the rocket goes, of 2,190 meters. Okay, so that's part A. Now we want to find how long does it take for the rocket to come down. So to do this, we want to use a position as a function of time. So our final position is going to be 0 when the rocket hits the ground again. Our initial position is its maximum height, it's 2,190 meters. At the apex of the rocket's trajectory, there's no velocity. So all we have is just 1/2 times gravitational acceleration on Earth, which is 9.81 meters per second squared, times t squared, where t is what we're trying to find, the time it takes to come down. This gives us a time of 21.1 seconds. That's part B. And then finally, part C is what is the final velocity just before it hits the ground. Well, this is simply going to be given by the final velocity is equal to initial velocity plus acceleration times time. Our initial velocity here was 0. It's at the apex of its throw, or of its trajectory. So this is just going to be equal to negative 9.81 times 21.1 seconds. Gives us final velocity of negative 207 meters per second.